across industries. But before that, let me express my gratitude to each one of you for attending these webinars. This shows the appetite for your learning new things, irrespective of the age at which you are. So thank you so much. Having come across this last 2 years has been tough for all of us due to this pandemic. And now when we are gradually coming out of this, it is time to move on and stay connected on new things and do the things as we were doing in 2019 in pre-COVID area time. So for the ground rules, I think it has already been expressed in the video, so I need not to explain it again. Please maintain high energy. Let it be an interactive session. We are going to have a lot of conceptual things today. Today's webinar will equip you with so many concepts where you can think and try to upgrade your existing system in various ways. We will be taking up each and every system, each type of system which exists in the premises of various industries. So friends, before I start, let me just give you a little brief about this series of innovations. We already have 2 webinars. Today is the 3rd webinar of this series. And the 4th webinar is going to be there on 11th of March. And after that, we will be having a quiz contest on the same day. And we will be recapping all these 3 webinars on 11th of March. And the quiz contest will be set up on a MCQ type of questions. And it would be online for 10 minutes. And the winner of the quiz contest will be awarded and interviewed for our e-magazine suitably. So let me start today's proceedings. Let me just share the screen. So I hope the screen is visible to everyone. Please say yes in the chat box if it is okay so far and I'm audible and a screen is visible. Thank you for your response. So as I mentioned, let us start today's discussion on upgradability of existing APC systems. As you know, these emission norms are getting more and more stringent across industries. And various industries are having the air pollution control system, which is either outdated or needs some upgradation for improvement in efficiency, right? So before we make it, let us just see how the technology progression has taken place in Indian market on APC systems. You all must be knowing there are 2 types of category of the system. One is the dry separation and other one is the wet separation. And in the dry separation, most of you must be using at present either back filter, ESP or multicyclones. The era in 1970 started with gravely settling chamber where the velocities of the gases were reduced suddenly and the bigger particles were separated in the gravity separation chamber. And then it followed up with cyclone, then multicyclone, then back filter, then ESP. And the latest in the series is electrified gravel bed precipitator. A combination of ESP and EGB is MEPA. MEPA is a new technology for the Indian market. We have done a couple of projects already, and this is called maximum efficiency particulate abatement. This is from Europe. In the wet separation technology, it started from wet cyclone. That means when the emission norms started becoming more stringent, then the dry cyclones were converted into wet cyclone and the efficiency was increased by spraying the water and increasing the density of the particles, correct, for better separation. And then the different kind of wet scrubbers came into the picture, starting from 𝐔𝐩𝐠𝐫𝐚 scrubber, high energy, followed by spray towers, then sieve tray units, then night tray units, then fixed vane scrubber. And the latest in the wet separation technology in the world is wet ESP, wet electrostatic precipitator, which we call WESP in short. So if we talk about the top two most advanced technology in the world on particulate emission, the dry, it is EGB and MEPA, and wet, it is wet electrostatic precipitator. Now, as you know, that ESP, back filter, and wet scrubbers are the most common technologies available in the industry. Every industry will have a different kind of, like some industries are dominated with ESPs, some industries are dominated with back filter or wet scrubbers, or it is a mix of either of the one. So presently, if you look at on an average basis, you find that ESPs are delivering to the tune of 80 to 150 milligram, the current old ESPs, and 2 to 4 field is the configuration, either 2 electric field or 3 or 4. Whereas back filter are operated on an average from 50 to 80 milligram with a air to cloth ratio of 0.5 to 2. It depends on the type of dust. If the dust is very, I would say it is the dust emissions are very high in quantity and very fine, as well as it is very sticky, then the ACR of 0.5, 0.6 is taken, like normally in EFB fired boiler or spent wash fired incineration. Or for normal cases of coal, it goes from 1.2 to 1.5 or up to 2, depending on the efficiency requirements. The wet scrubbers is a most versatile equipment which is available in the industries, and it can be operated easily with 100 to 150 the older designs. Though the new designs are available which can give you even below 50 milligram, but normally 100 to 150, these are the most 3 common type of wet scrubbers in the industry. One is the spray tower, venturi, or tray. When I say tray, it is either sieve tray, that is a perforated tray, or a night tray. So having known these 3 prevailing technology, the most common technology in the industry, and we also know their limitations and the present operating conditions varying from 50 to 150 milligram, correct? Now, if we look at the norms, which is getting more and more stringent, you find that earlier the norms were 150, and now 150 is reduced to 50, and for new plant, it is going down to 30. That means with the existing system in place, we either need a further reduction of 67% coming down from 150 to 50, or 80% for the new plant coming down from 150 to 30. So your efficiency of the equipment has to go up by the equal amount. It has to go up by either 67% or 80% for most of the plants. The 50 milligram is after January 2003, and for the new plant, it has come down to 30 milligram already. So the 30 milligram units, if being operated at 150 or the design is 150, you need to enhance the efficiency by almost 80% plus from the existing limits. So what are the different configurations available for upgradation? Today's webinar or today's topic is going to equip you only with the conceptual, I mean the ideas that how to upgrade your existing equipment. Then depending on the site to site, the project to project, or the equipment to equipment, the fine tuning can be done. But if you look at the concept, the most common way of upgrading the existing ESP is just to add another field. If your ESP is 2 field, you add 1 field or maybe 2 more field, and try to upgrade the efficiency of the existing ESP in an industry. This is a very normal and conventional way of upgrading the equipment. The other way of upgrading the equipment, another way is upgrading the equipment to reduce the emissions. The first methodology can bring you down to below 50. Coming down below 30 would be difficult with this configuration if your particle size distribution constitutes more than 10% of the particles below 5 micron. Then even if you add 3 field, 4 field, nothing is going to happen if the constituents are below 5 microns, because ESP has got a limitation arresting 5 micron below particles in the dry electrostatic precipitator. So if you want to come down to further 30 milligram, then the another alternative for upgradation is to make it hybrid. That means the last 2 field or 1 field of ESP can be converted into the back filter, fabric back filter. So this is another arrangement which can work, but it comes with a caution. And the caution is that this should not be considered for those type of ash which has a high sticky nature, hygroscopic nature of dust. Because what happens after the ESP, you are left with particles which are below 10 microns. Most of the particles or the majority of the particles are below 5 microns. So when the back filter is operated only with fines, then there is a cake formation on the back filter which is too difficult to dislodge by purging air. If it is mixed with heavier particles and then fines, then the cake removal is easier. So such type of hybrid or such type of configurations are not giving proper results if the gas particles are very sticky and hygroscopic, contains lot of alkalis. So this is a caution when you think of upgrading your existing ESP with this model. And the most advanced and most innovative way, this is, we call it as a smart way of upgrading your ESP, is putting up the EGB at the outlet. You have a 2-field ESP attached with a EGB. EGB is a electrified gravel bed precipitator. Because this is a new concept for Indian market, I will just take some time to explain you what it is. Okay. But the most effective way of upgrading ESP is to convert it into a MEPA, which is an integration of ESP with EGB. EGB is also a type of ESP, but it works just reverse principle of ESP. It is a dry system. Here the gravels are used as a collecting plate or collecting surface area. This is most suitable for high resistivity dust, which cannot pass the current. They use only the voltage for getting polarized. So this is the concept of EGB. In the EGB, there is a vessel, and that vessel consists of a gravel bed. You know the gravel, it is a normal gravel, pea gravel, which you found across rivers. So this gravel bed is having a high thickness to the tune of 300 to 500 mm. And the gravel size varies depending on the efficiency requirement. It varies from 3 mm to 8 mm, 10 mm. And the gravel bed is embedded with discharge electrodes. And this discharge electrode is given a high voltage to the tune of 15 kV to 30 kV. So what happens when the high voltage is given to the gravel bed being the non-conductor of electricity, it cannot pass any current, but it gets polarized. It gets a static charge, half gravel gets positive and half gravel gets negative. It is a balanced charge. And these gravels are moving from top to bottom with a very, very slow speed. And when the gas carrying the negative charge from the ESP, particles carrying the negative charge from ESP below 5 micron or below 10 micron, when they pass through this gravel bed, they get stick to the positive side of the gravel and get separated. And clean gas goes upward and goes to the chimney. And these gravels are taken out. It is a closed loop system. The ash coated gravels are coming out, and then there is a gravel cleaner, and then clean gravel are going up and getting back into the system. And this dislodged ash from the gravel is collected through a dedusting cyclone or a small bag filter, and then taken to the hoppers or the silo. This is the internal view of EGB, electrified gravel bed precipitator. This is, as I said, this is a new type of ESP which uses only the voltage for collection of particles, and which is very much suitable for all type of ash which cannot be used in a normal ESP. Whether it is high resistivity, whether it is sticky, whether it is hygroscopic, whether it contains alkali, or whether it is a corrosive in nature. Because the gravels are used which is non-corrosive, gravels are cleaned outside, so there is no problem of stickiness. It is not being cleaned inside, it is being cleaned outside the system, so the stickiness factor is not there. Resistivity is not a factor because there is no current in the system, it is only the voltage. So all these things favors this new type of electrostatic precipitator, which is going to have a high potential of uses in Indian market. So far, we have got a patent of this, and this technology was innovated in MIT, USA, and we have got the patent rights. And we are now, introducing this technology for all type of applications where the normal ESP has got a limitation. So it could be applied to mustard husk fired boiler, it could be applied to paddy straw, it can be applied to other incineration boiler like MSW, like spent wash, like palm shell, palm fiber, and EFB, the empty fruit bunch. And also it is very much suitable for high temperature gas purification, where the temperature of gas is up to 800, 600, 700, or even 1000 degrees. Because gravels are subjected to high temperature and there is no threat of getting corroded or eroded. This is how the gravel bed is maintained, and it is slipping down to the bottom slowly and gradually. You just see this video. And this is coming down at a very, very slow speed, and gas is passing through this. So there are two types of separation. One is the mechanical separation because of the gravel bed, and second is the electrostatic separation because of the gravels getting polarized and having a positive charge. So if you look at the efficiency curve, you find that even for particles below 2 microns, when the electricity is on, you have an efficiency of 100%. Up to 2 micron, you have an efficiency of 90% without electricity. When the electricity is on, then you are touching the 100%. And even at some micron particle size, you have a very high efficiency. At 1 micron, you have an efficiency of almost 99%. So this is a very good fit for the ESP upgradation. Whenever you are looking for to increase the efficiency of ESP and reduce the emission to well below 30 milligrams. This could act as a very good polishing filter for removal of very fine dust which is left by the ESP. And this is how the gravels are coming out from the system, which is ash coated. And after the this ash coated gravels are going to the gravel cleaner, and after the cleaning, you see how the gravels are changed in color. And if you look at the advantages of EGB versus normal ESP, you find that EGB has got a very high collecting surface, because one vessel contains approximately 100 tons of gravels. And if you calculate the total surface area of these gravels divided by 2, because most of the time half gravel is used for deposition until and unless it gets turned up during the travel. Okay. So 10 to 20 times collection area, and the footprints are 1/5 or 1/6 of the normal ESP. Even gas distribution, power consumption is very, very low because there is no power consumption in the TR set here. TR set is using only the voltage. There is no current. So power consumption in TR set is 0. Or that is how the power consumption is limited to the auxiliary, which is the bucket elevator to carry the dust particles, the gravel particles, and in a dedusting fan for removal and cleaning of the gravels. High efficiency on submicron particle. It can handle high resistivity dust, as I mentioned to you. No wrapping re-entrainment. Friends, this is the most important factor which goes in favor of favor of EGB as compared to normal ESP. In normal ESP, there is a wrapper. Whenever there is a wrapping cycle, you find the chimney gases going grayish or blackish, because your cleaning of collecting plate are in the gas stream. Gas is going at the same time you are hammering the plate, so fine particles tend to go along with the gases and in the chimney. Here, because the gravels are cleaned outside the gas part, there is no threat of remixing of particles back to the gas stream. So this is a very big advantage if you compare with a normal ESP working of EGB. That means whatever deficiencies or whatever limitations are there in your existing ESP, the EGB is able to take care of all those deficiencies and all those shortcomings and limitations by putting EGB in the outer stream of ESP and making it as a high efficiency polishing filter and converting it into MEPA. Modular shape design and a smaller footprints. So friends, so far, if you are with me, please write yes in the chat box so that I understand that you are following the concept before I proceed to the next. Just a moment, I have some technical glitch. Thank you so much for sharing your views. Okay, thank you. So let me just proceed. So now, just recap, we have understood how to upgrade our ESPs, how to upgrade our bag filters, correct? Sorry, so far we have understood ESP. Now coming back to the bag filters. Whosoever is operating bag filter must be knowing how to increase the efficiency of any bag filter. So easiest way is to add the module. If you have a 4 module, you just add 2 module and increase the efficiency and reduce the ACR accordingly. This is one very conventional way of upgrading the efficiency or the collection from the bag houses, correct? What are the smart ways of doing it? The another way of doing it is changing the type of bag. If you have a normal bags, you change it to PTFE or other type of bags which has a low porosity and better filtration. So the other methodology is changing the bag, keeping the same housing, but you change the bag to a better bag with more efficiency. And another way is to change the type of bags from normal bags to the plated bags. Plated bags has got a high collection surface area, and you can increase the efficiency of the bag filters within the same chamber. You can get much higher surface area, almost 1.8 to 2 times in the same collection chamber. So when it comes to bag filter, either by increasing the module or changing the bags or changing the type of bags. So these are the 3 methods of doing it. And the 4th method, which I'm going to explain, is not yet tried in India. but it is a very good method which has been tried outside India, converting the back filter into a fabric back filter. So here what you do, you install a pre-charger to negatively charge the particles coming from the source, and then allow agglomeration of the particles on the surface of the bags because of this electrostatic charge. So this is called electrofabric bag filter. That means the concept of ESP and bag filter is integrated here. So this is a smart way of doing it. The technology in India is not yet there, but we are trying to have some collaboration very soon for upgrading and increasing the efficiency of bag filters down to below 10 milligrams in near future. So we have covered ESP and its upgrading methodology. We have covered 4 methods of ESP upgradation, 4 methods of bag filter upgradation. Now coming to the scrubbers, I'm sure most of you must be having scrubbers in your plant, especially the sugar sector and other biomass sector has a lot of scrubbers. And so friends, can you just be a little more energetic, and can you just share your type of system which is available in your premises? Just within, we'll take a 30 seconds. Please write your type of system which you have in your premises, so that I am able to connect that what type of systems are more within this audience, and I focus more on that particularly. Okay, scrubber, ESP plus EGV. Okay, Venturi scrubber, then ESP. Yes, please put. We are 66 on this platform. Back filter, ESP. Okay. Back filters, ESP, wet scrubbers, back filter. Okay, thank you so much. I think we have the mixed of ESP, back filter, and wet scrubbers. It's the audience is divided. I think many of you have ESPs and back filter as well as wet scrubbers. So all are equally placed. So let me now come to the scrubbers. The most common and the oldest design of a scrubber is a Venturi scrubber. Everyone knows. The Venturi scrubbers were very prominent in cement industries and other industry where the particle size was bigger, and the separation was easier even at a low pressure drop, say about 150 millimeter water column. You get a reasonably good efficiency on a Venturi scrubber. But as the particle size became more and more finer, especially on biomass, especially on coal-fired pulverized fuel or any other liquid fuel, then the efficiency on very fine particulate of below 10 microns, the Venturi scrubber had a limitation. It is not so that it cannot collect, but it can collect, but needs a very high pressure drop, which increases the power consumption on any Venturi wet scrubbers. So there are 2 ways of upgrading the efficiency of these scrubbers. Either we increase the pressure drop to a great extent, change this throat velocity, and have a better efficiency of the scrubber. But then it will lead to a very high consumption of power or the delta P across the system. So what are the other ways we can play with a Venturi scrubber? We can play with a Venturi scrubber to convert it into a vent tray scrubber. That means you retain the Venturi as it is, but put a tray here, perforated tray, which is called night tray, and whatever particles the Venturi is separating, let it separate. Whatever is balanced, which is very fine, that can be taken care of by the tray. So this becomes a vent tray scrubber, which can give you an efficiency increase by more than, if I talk in terms of numbers, if your efficiency presently is 80%, it can lead to 95% by putting a tray in addition to this. So your 130 and 150 milligram can cut down to below even 80 milligram in most of the cases, especially on biomass. If you do not have margin in the ID fan, even for the tray would need about 50 to 70 mm water column of extra pressure drop. But if your margin is limited, even lower than this, then you have another option to convert the venturi into van spray. Van spray means have a spray tower and let the venturi be retained. So that is called a van spray model. Additional pressure drop is going to be only 20 to 30 mm, but it can lead you the efficiency increase not to that extent, but it will lead you to increase by say 5% or 7%, not much. So this is how you can upgrade your venturi scrubbers. Now coming to the second type of scrubber, which is very common in the industry, is a tray scrubber. So upgrading the tray scrubber is very easy, because tray scrubbers are known for the best upgradability for meeting the future norms. And the upgradability is, if you have one tray, put two trays. If you have two trays, put three trays. At the cost of pressure drop, of course, each tray will add about 60 to 50 mm water column extra pressure drop, but it gives you much higher velocity. Whatever particles are left out in the bottom tray goes to the second tray, and second tray goes to the third tray. But here the design of tray is becoming very crucial. Normally what people do, they just add another tray of the same size and same configuration on the second stage or third stage, which is not right. The second stage and third stage tray has to be designed in a different way. It will have a lower perforation gradually. If your perforation size is 8 mm at the bottom, the second one will have different, and the third one will have still finer. And the open area ratio will also differ from plate to plate. So this needs a proper engineering. But if you are able to do the proper engineering, then it can lead you to give easily below 40-50 milligram. And the pressure drop is going to be only approximately, with three tray configuration, around 200, 180 to 200. That means whosoever is having a tray scrubbers can think of this option of upgrading the tray scrubbers from one tray to multi-stage tray, and depending on the efficiency requirements. The another type of scrubber, which is relatively newer in the market, but we from Enviropol have already installed about 50 scrubbers of this type in the industry, replacing the old venturies, many venturi scrubbers, is a fixed vane scrubber. This is a technology from US again. This fixed vane scrubber has got a vanes. There is no perforation, there is no nozzle. So this system is known as a chokeless scrubber. Normally, venturi scrubber gets choked if your recirculation water quality gets deteriorated with high TSS. The tray scrubber also suffers from choking if the quality of water, return water, is not good, because the perforation gets choked. So we have brought this new type of a scrubber in the industry, which is called the fixed vane scrubber. This does not have any nozzle. This does not have any perforations. It works on the principle of momentum separation by creating a whirling motion of the gas and then putting the water, just water spray with the pipe, not with nozzle. So this creates a high efficiency of separation, followed by the demisting, which is again a vane, demisting vane. So this scrubber is also known for higher upgradability by adding the vanes. If you have two vanes, just add one more vane. So it becomes the multi-stage vane scrubber, and it will give you 60 milligram to 80 milligram easily with three vanes. Even with two vanes, we have got 40 milligram in Thailand in boilers up to 170 tons per hour capacity. And this is again the modular in design. So depending on the fuel, Depending on the type of fuel, we can decide the number of stages, we can decide the efficiency and the particle size distribution, correct, at the outlet. So we have so far seen three types of scrubbers. First one was Venturi, tray, and now the fixed vane. Another type of scrubber which is not so common in India, but in African continent and many other places, this low pressure drop scrubber is used. This is the most trouble-free scrubber in the scrubber design. The only thing is that it uses lot of nozzles, but the pressure drop is very, very low. So this is called cyclonic scrubber. You have a cyclonic type of connection, and in this wrapped cyclone duct, you have many nozzles which are put up at every cross section of duct, so that to create a curtain, and the gas is passing at a high speed through that 3 or 4 stages of water curtain, followed by the separation of mist through a whirling motion or the momentum centrifugal motion of the gases. So this is a cyclonic scrubber which is normally used in developing countries or underdeveloped countries where the norms are there up to 200 milligram. So 150 to 200 milligram is a normal course of outlet emission from this. Quite popular in Vietnam and many other areas like Philippines, Vietnam, and Tanzania. This is very much popular. Now, how to upgrade this cyclonic scrubber? You can convert it into a CV scrubber, which is called cyclonic vane scrubber. So whatever you are collecting from this cyclonic action and the duct configuration, you collect and then add one vane and create a wet wall on the surface. You can go below 80, near 80 to 100 milligram from this configuration. So friends, we have understood so far. Let me just recap for all of you. The ESP upgrade, which is 4 types of upgrades available in ESP, 3 conventional, 1 is with EGV, which is a smart way of doing it. Then in back filter again, we discussed 4 type of convergence or the upgradability. And now in the scrubber, we have discussed 4 type of scrubbers, and each scrubber has got the 1 or 2 type of upgradability prepositions, right? So let me go forward. Another way of reducing the particulate emissions to below 10 milligram, 20 milligram, or 30 kilogram, that means the topmost upgrade of scrubbers available is to convert them into a wet electrostatic precipitator. So the bottom portion remains the scrubber, and on the top we just insert the wet electrostatic precipitator module, which contains of collecting pipes, electrodes, and discharge electrode, insulators, and the TR set. So you can easily convert your existing scrubber into a wet ESP. So there is no need of extra space. You can just build in vertically. There is no need of changing the duct and replacing or repositioning of ID fan and chimney. Unlike your normal ESP, whenever the people are replacing scrubbers into a dry ESP, you have to shift everything away from the boiler, like chimney and ID fan. But here, when you go up and convert it into a wet ESP, you don't have to shift the layout of the boiler. So let me just give you a little brief about the wet ESP. Wet ESP is nothing what a normal dry electrostatic precipitation concept, but the first step and the last step is different. That's all. The first step, that gas has to be saturated, unlike a normal ESP. The wet ESP works on the saturated gas. When the gas is wet, having a high percentage of moisture, then the wet ESP performance increases multifold, because then resistivity of the particles does not matter much. The water film over the particles creates the charge, and water being a good conductor of electricity, the charging is very, very fast. If your dry ESP takes 80 kV, For the same efficiency, the wet electrostatic precipitator takes only 30 kV. So this is the difference in charging. It has a very high efficiency. It can go up to 99.99% and can lead to give you below 10 milligrams. In many cases, we have seen it running. So the first step is gas conditioning. And the gas conditioning is done in the scrubbing zone, which is already available if you are upgrading a scrubber. Then corona and charging is same. The discharge electrode has got a negative charge and it gives on the particles. The collecting plates, here you have a pipe or hexagonal tubes of collecting surface. It is grounded and given a positive charge, and then migration and precipitation is same as normal ESP. Then particles are removed by flushing the electrode instead of wrapping. So this is the difference as compared to normal ESP. This is the type of electrode, discharge electrode, and this is the type of collecting electrode. You can have round, plate, square, or hexagonal. You can see the collecting electrodes of a wet ESP in picture. This is the internal view of a wet ESP. Bottom portion, you have a tray scrubber followed by the wet ESP, and then it can lead you to give easily below 20-30 milligram, whatever is the efficiency requirement or the outlet emissions requirement. We have a Swedish collaboration for this technology, and we have supplied already 7 systems, and 2 are further under installation in various industries, including one in sugar and in steel industry, in aluminum, and in zinc smelter plants. So we have now 7 installations working in India with the Swedish collaboration. If you look at the versatile nature of the APC across the type of system, you find that wet ESP is the most versatile equipment, which takes care of solid particulate matter. It also takes care of gaseous pollutant to a great extent. Whatever gaseous pollutant which can be condensed at a dew point, this separates that mist gets charged and aerosols are removed with the effluent. So this is a broad comparison. You find that wet ESP has all ticked marked. Now, having gone through the various type of concept which can be applied depending on the industry, depending on the existing type of APC, we should know where are we heading for in future. Time will come very soon when we will have to compete with European standards on emission levels. The European standard on emission is depend and based on a BAT, they call it best available technology. And based on BAT, these are the standards which are displayed on the screen. You find that PM in the range of 2 to 5 milligram only. We are talking of 30 here today. Maybe 10 years down the line, with the type of commitment our nation has given to be net carbon emission free or zero by 2070, we have to be following these European standards on emissions. And if you look at this SOx, NOx, and mercury heavy metals, so what should we do as an industry on environment? So friends, after this, we will be talking about our future as an industry on emission control or on pollution control. I'll give you a couple of hybrid technologies which can be explored to even meet these pollution norms of European standards. I hope everyone so far is with me. If yes, please write in the chat box following the concept so far. Please write yes in the chat box. Before I proceed next, let me just understand if everything so far is audible and you are following the concept given so far. And then we will be talking about the hybrid technologies to reduce and meet BAT standards. Okay, thank you so much, friends. If you don't mind, there is a request from a couple of attendees to just re-explain the EGB, which is new. So if you permit, I'll just take 2 minutes and go back to that slide and re-explain on EGB, because request has come from 4 or 5 attendees. Or I'll do one thing, let me just finish it, and then at the end, I'll take it up EGB 2-3 slides once again. Thank you. So let us talk of our future now. So I'm going to the screen. On a screen, you see that there are 4 types of hybrid technologies which has got a good potential for Indian market. The first hybrid technology is a revenue generating technology for the biomass industry, where the biomass dryer is attached with a wet ESP. This is the biomass dryer and it is attached with a wet ESP. So this model is a revenue generating. You save the fuel, you dry the fuel by direct mixing of the flue gases with the fuel in this flash tube. During this travel, what happens, your ash particles, unburnt or partially burnt particles, they get captured with the biomass, and biomass is separated after drying and goes back to the boiler furnace. And the partially clean gas, when I say partially, I'm talking 90% clean gas, comes to the wet ESP, and then it is further cleaned and goes to the stack. So this model has been awarded recently by CII as the most innovative product of 2021 on national level. We have got a patented, and we are now exploring this model to be used in sugar industry as well as in paper industry. One installation is already commissioned and running well for last about 2 years, and we have done all sorts of testing and found this revenue generating model a way forward for converting the air pollution control into a revenue generation for the industries like sugar, paper, or any other biomass based power plant to reduce the emissions to even below 30 milligrams per nanometer cube. And the second hybrid, if you look at, is a multi-pollutant removal system. You have a normal ESP followed by FGD and then followed by wet ESP, and this gives you the removal of SOx, removal of particulate matter, and if you can have activated carbon filter or ammonia injection, you can even get rid of NOx and heavy metals. So this is another model which is quite popular, but it is expensive, of course, because it contains 3 main equipments in one series. The third hybrid, as I explained to you, is a ESP with back filter with a caution for normal ashes, not for sticky dust and hygroscopic dust. And the fourth upgrade is hybrid MAPA, maximum particulate efficiency system, which is ESP attached with EGB. So friends, future lies basically in the hybrid system, the standalone technology. Either it is a scrubber, or it is back filter, or it is ESP. Unfortunately, our CPCB defines only these 3 equipment as a equipment for pollution control or emission control. But if you use either of the one, we have a limitation. We can use them up to the current pollution norms, definitely. But as the norms become more stringent, as we go in future and expecting to meet European standards, we will have to go and we will have to adopt the hybrid system, integrating 2 similar technologies which can work together and can adapt well and can give you multi-pollutant removals and can give you the SPM of below 30 or below 10 milligrams, depending on the progression on the emission norms in future. So the two most promising technology we have learned today is wet ESP and EGB. In the wet spectrum, the wet ESP is the most advanced. In the dry spectrum, electrified gravel bed precipitator is the most advanced technology. So we will have to study these technologies for the adaptability in your respective plant and find out if we can target achieving below 30-20 milligram, adding these equipments in the existing APC devices. Or you are capable of doing it only by just upgrading your existing equipment by other methodology, which I explained to you. So call is yours. We can study wherever you approach us. We will find out what is the best way of doing it. But before you go ahead with the upgradation, our suggestion and recommendation would be to study all these concepts and first rule out one by one and then go with the final one. Instead of going directly with one or two suppliers recommendation, you should not do that. Engage with a proper study, and the proper study would need some inputs. And the inputs are that your existing system collection efficiency is what and at what size of the particles. That is very, very important. When we talk of efficiency, we just talk plain efficiency without attaching the efficiency for the respective particle sizing. So if your collection efficiency of ESP is 99%, but it is leaving all the 5 micron particles, then it is not going to serve your purpose in the future times to come, because even if you have a 10% or 5% particles below 5 microns, it is not going to make the emission. I mean, you are not going to meet the norms of below 10 milligram or 20 milligram. So the time has come to study each and every aspect, see all the concepts, make a proper comparative study and see how can we future secure. It is not only the investment for today, it is going to be the investment for future as well. I think I've explained you both the concept, and both of them are capable of giving you below 5 milligrams. If it is designed for that purpose, then wet ESP is equally capable of reducing 5 milligram per NM3. Similarly, the EGB can also give you below 5 milligram. Believe me, I have seen both the systems running in Sweden at 3 milligram per NM3 on a wood-fired boiler EGB and on a chemical incineration, the wet ESP. So it has a good potential. The only thing is at what level we are looking forward to operate in India at the moment, whether we are only trying to fulfill the requirement of CPCB or we want to be future secure and also seeing our social responsibility to cut down the emissions, not only particulate, but also the gaseous pollutants. See, ball is in your court, and it is our duty to keep you appraising about these new technologies, and the call has to be taken finally by the industry owners, depending on their social connect, as well as depending on their motive for becoming future ready. So thank you so much. This is what was on today's webinar. And as requested, I'm just coming back on the EGB before we close. Please do not go away. We have a couple of announcements to make, very important announcement for the next webinar and quiz contest. So I'm just coming back on EGB to explain you. Yes, to all my friends who have put up the question on the chat box, how it works. Let me just explain you how it works. As I said, EGB is a vertical type of electrostatic precipitation. Here, the gravels are used as a collecting surface. In normal ESP, you have collecting plates, which are grounded and having a positive charge. Your particles are having a negative charge, and they get migrated and collected on the collecting plates. And then wrappers are used for dislodging, and then ash is removed and clean gas goes out. Unlike that, here the gravel surface are polarized. Polarized means that you give the voltage and it becomes balanced charged. The half of the gravel surface is positive and half of the gravel surface is negative. And when the negatively charged particles are coming in contact with this gravel bed, they get stick to the positive side of the gravel because of this polarization of gravels. It is just like a principle. When you rub the plastic rod on your hand, you find that charge is there. So it is in a similar way. Very mild charge is there on the gravels, and when it comes, negatively charged particles are coming here, they get stick to it and form a layer on the gravel. And these gravels are not stationary. These gravels are moving from top to bottom at a very, very slow speed. The gravel takes about 7 hours from coming here to here. That means the same gravel is there in the system for 7 hours. So speed is very, very low. And when by the time the gravel reaches to the bottom of this, the ash is coated on the gravel, and gravels is then taken out with a vibro feeder here. As you increase the speed of vibro feeder, it is VFD control, the evacuation rate increases. When evacuation rate increases, the efficiency is down, pressure drop is low. But when you control this speed, the efficiency goes up, the pressure drop is slightly increased. So we have a set point here for the rate of evacuation of the gravels. And when the gravels are coated with ash and it comes out from this zone of electricity, it falls in a gravel cleaner. This is a gravel cleaner. The gravel cleaner uses the mechanical force and the pneumatic pressure of air to clean the gravels. Because what happens when the gravels are there in the electrostatic zone, the ash is tightly held on that. But the moment it comes out from the electrostatic zone, ash becomes loose. So with a slight air pressure and the vibration, the ash gets away and clean gravel goes back to the system through a bucket elevator. And the ash with a dedusting air gets to the cyclone or a small dedusting back filter. Depending on the type of material, we can use a dedusting vent filter or a cyclonic separator of high efficiency to remove these particles. And the air, dedusting air, can be remixed with the system or can be let out to the chimney. Both options are available. And this is the internal view. This what you see, this is the electrode case, emitting electrode case, which is embedded into the gravel. And this is hang on 8 numbers of insulator, which is connected to the TR set on the top. And this is how it works. The gravels are coming down slowly and gradually. Gas is passing through this at 90 degree. And then you have an efficiency curve, which says up to 2 micron with electricity on, you have 100% efficiency. Even without electricity on, suppose your TR set is failed or some electricity issue, even the gravel filter gives a very good efficiency of 90% up to 2 micron. And 5 micron, again, it is 100%. That means even without electrostatic precipitation, the gravel bed itself is capable of reducing the dust load to a very, very low limit. Whenever you are needing 60 milligram, you don't have to charge it. You can just use it as a mechanical filter. So this is the capacity and the capability of EGB from that point of view. And this is the gravel coming out. This installation is on a spent wash fired boiler in DCM, which spent wash, if you know, many of you must be knowing, all sugar professionals, is a most dangerous as a fuel in the boilers. It has high potassium. It has 40% particles are below 10 micron, and the quantity of dust loading is about 30 grams. And dust is very sticky, and it is hygroscopic in nature. So all negatives are there in this particular fuel. and we have successfully installed it on this the worst kind of fuel and the worst kind of application if you look at the application point of view of EGB. And this has worked very successfully on this tough conditions. So I am sure on other fuels which we are talking about, this is going to be a cakewalk, and it will give you very, very low emissions at the outlet of this. And this is the gravel cleaner. You have an air pressure, and then you have various pipes so that the gravels are going from one stage to other stage to other stage and getting cleaned with the mechanical force and pneumatic force. During the startup, even we have got 6 milligram, though the boiler was being operated at a low load, but we crossed 6 milligram we touched at one point of time from this installation. So I hope this EGB is now relatively more clear, and these are the advantages. If you have still something to be asked, you can put up your questions in the Q&A box after a few minutes when I take up the question and answer. So friends, whosoever had mentioned wanted to understand little more in the chat box, please write again in the chat box if you are clear now. Okay, please stay for some more time. We have a couple of announcements to make. Thank you for your response. So friends, we are going to have the next webinar on 11th of March from 4 p.m. And this webinar is going to be very, very generic. It is not on technology. We are diverting a little bit and giving whatever we have learned in last 3 or 4 webinars so far. We are going to have a overall perspective that if we do not adopt the right technology, what we or our next generation is going to suffer. So we are coming out with a very impactful webinar on 11th of March on environmental health hazard from various pollutants. Believe me, you are going to enjoy it and learn a lot. It is going to unfold each type of pollutants, what it is harming, whether it is harming the human or it is harming the nature or the plants or our water tables. So all those things are put up nicely in this particular webinar. And so having learned all these technologies, we should know what if we do not use these technologies rightly. So we have to learn the effect or the impact of this environmental on our health or our generations to come, the bad effect of these pollutants. Also, we are going to have a recap of first 3 webinars quickly in 10 minutes. So it is going to be a sort of master webinar, which is going to be displayed on 11th of March. And this will be followed up with a quiz contest. We are going to have a recap of all the 3 webinars previous to this. And this quiz contest will cover all the questions from all the 4 webinars. And this quiz is going to be for 10 minutes online MCQ questions. And please enjoy this quiz and take it lightly, and let the winner be interviewed in our Green Heroes magazine, and we will be giving happy to give them the suitable rewards in the form of branded Green Heroes merchandise, certificate, as well as a surprise gift. So please be active, and whatever, if any one of you have not attended the previous webinar, you don't have to worry at all. The recap will cover all those main points of the previous webinar, so that you will be ready for answering those questions in the webinar. So thank you so much for your attending this webinar as well. Please do not forget to download your participation certificate after the Q&A session. The link will be provided soon, and whosoever wants to download the certificate of participation, you can do so. So the forum is now open for the Q&A. Please type your question in the Q&A box, in the chat box, sorry. Thank you so much. Yes, friends, I'm just running through the questions. Good, there are many questions today. Yes, the first question is from Abhishek, Mr. Abhishek Jaiswal. Please give some solution for bag filter DP issue. Friend, bag filter as such has a limitation in this particular aspect, what you are referring to. You are not only the one who is suffering from this issue, many other people who are using a bag filter. This is a very common issue, and it can only be resolved by having a proper purging system, or if the bags have got damaged. Because normally what happens over a period of time, your porosity in the bags gets choked up, and that is not even cleaned after that with the air pressure or whatever you have. So it has to be inspected properly. If it is because of the damage or the choking of bags, this is an irreparable problem. You will have to replace the bags. But if it is a problem due to the inefficient purging, then it can be resolved. So we can discuss this point on case-to-case basis. Or if the bags are getting choked up more oftenly, then you may have to think and find out the right kind of bag for that particular application, because you have different kind of bag metal, fabrics available in market. So next question is how to maintain temperature range of ESP, fixed or variable, Mr. RB Singh. I've not followed your question, but as I understood correctly, you are saying how to avoid the temperature drop in the ESP. Because your source, which is coming from the boiler or any other process, has got a certain temperature. And during the travel of ESP, you loses some temperature due to many factors, which includes your conduction losses through the casing. So the proper insulation is required. And also it depends on the velocities you are maintaining inside. So temperature can be controlled by having the right kind of insulation. Plus at the bottom where the this RAVs are there, you need to check if there is a air gap or there is a air ingress from that particular region. So ideally, if you have a 3-field ESP, the temperature drop should not be more than 5 to 7 degrees. If it is coming more than that, that means you need to check and plug all those air ingresses or the leakages, either from the top or from the bottom or through the conduction from the damaged insulation. So the next question is from just a minute. I think I've left a couple of questions on the top. Let me just go back. Can we, Rajdeep, from Mr. Rajdeep Hegde, can we use only EGB in boiler without ESP? Mr. Rajdeep, only EGB has got a limitation. It is normally act as a polishing filter. It can be used, but what happens if you have a more than 2 grams inlet dust concentration at EGB, then your gravel circulation rate increases drastically. And as you have more gravels and faster evacuation, the erosion issues of the vessel goes high. So far we have a design limited up to 2 grams. as an input dust concentration. So it depends on what type of boiler you are talking about. If it is a coal-fired boiler, yes, you will have to have two-field ESP minimum as a pre-dust collector. If it is a boiler having 5 gram as a dust output, there you can have a cyclonic separator followed by EGB. So it depends on type of boiler. EGB normally is not used as a standalone equipment. Either it is hybrid with cyclone or it is hybrid with ESP. These are the two integrations normally used. But if you have some source which has a less than 2 grams per normal meter cube as an inlet dust concentration, definitely you can use EGB as a standalone equipment. I think I've replied Mr. 𝐂𝐻𝐠𝐫𝐚𝐝, same question. Membrane waste, yes. Plated bags gives more efficiency, yes. Electro bag filter can be used, all type of dust, slag dust also. Yes, Mr. Abhishek, this electro bag filter can be used, though it is not tried and tested yet in India. But definitely we will have to check on what all application it is running outside India. Mr. Mohit Kumar, night tray fluidized bed scrubber system. Yes, this is we call it as a FBNT, fluidized bed night tray. So now coming to further. Yes, next question is from Mr. Lalit. Please explain the disadvantage of dry ESP with respect to fine dust less than 10 micron. Mr. Lalit, as I mentioned that ESP is having a high separation efficiency beyond 10 microns. As you go down below 5 micron, the efficiency of the collection efficiency of the ESP decreases to a great extent. The reason is the charge. That one is the velocity of the what you keep in the system is about 1 to 1.2 meter per second. So at that velocity, very fine particles tend to escape, and they have a difficulty in charging, electrostatic charging. And secondly, the most important problem is the wrapping re-entrainment. There is an agglomeration of particles. The fine particles become bigger during the travel when it travels across the length of the ESP. But when it is dislodged from the wrapping hammers, then again it gets disintegrated, and some fine particles tend to go with the gas stream. So this is the reason why the very fine particulate matters are having a difficulty in ESP in charging as well as in re-entrainment of dislodged particles. Next question is from Mr. 𝐂𝐻𝐠𝐫𝐚𝐝. Please clear dry use pit, leaf factoring, apala, rice, husk, cotton waste, sugar, can use, etc. Mr. 𝐂𝐻𝐠𝐫𝐚𝐝, my question is not clear. We can talk on phone. And then next question is, in the sponge iron plant, we can definitely use very effectively these EGB as a great solution. The reason is that iron oxide particles are very resistive. I mean, they have a high resistivity, and higher the resistivity, better is the performance of EGB. So in a sponge iron plant, EGB can be a very good solution either after ESP or after multi-cyclone dust collector. Mr. Dilip from Yamunanagar, when there are many boilers, then each one require EGB. Yes, EGB actually is a modular design. Every, I would say every 20 meter cube per second gas flow, you need one vessel, approximately. That means if a boiler is of 40 ton, you need 2 vessels. If a boiler is 100 ton, you might need 4 vessels. So it is a modular design. We do not make very big size because then handling of gravels becomes very, very difficult in this. So smaller the sizes, better is the movement of gravel, better is the performance of the unit. So modular design is very popular. just keep on adding the number of vessels and increase the capacity. So different boilers will definitely need different EGBs, and maybe one boiler of higher capacity need 4 EGBs. Mr. Dilip, again, what is the basic material of gravels? Gravels are normal stone, pure pea gravels, what you get in the market on the river front and all. So there is nothing hidden science on it. It is a normal pathar gravels which you can easily get. The only thing is that it should not have a sharp edge. That is why we normally have a pea gravels which are rounded on the edges normally. Thank you, Mr. Piyush Kotia. Thank you very much for your greetings. And DCM plant locations, Mr. Anshul, it is at Dorala Sugar Works near Meerut on a distillery spent wash fired boiler. Then Mr. Sudhir Kumar Singh, CPCB issue a notification regarding interlocking of OSAM to the boiler if pollution level goes on higher than plant or automated install. What is your opinion about this? Yes, my opinion is always positive on such type of exercises. Whatever can make us more clean, whatever can make us more organized in this sector, it would be better for our generations to come. So as a environment, this technocrat, I would always prefer that all these technologies are properly done. It is not only for meeting the CPCB rules, it is also for our future generations. I think we need to connect this sector emotionally with all the operators. So it is for us, not for CPCB. So next question is from Dilip. Again, do you run as and when steam trial conducted in sugar plant? Do you run as and when steam trial conducted in sugar plant? Oh, this installation is on a boiler. So whenever the boiler is running, it is running always. If possible, about some more about principle and working of ESP. Mr. Anshul, as I explained to you, working principle of ESP is same as ESP, excepting the first and last step. The first step, the gas has to be conditioned and saturated. The last step, the gas, the particles has to be dislodged from the collecting pipes by water flushing, not by wrapping mechanical hammers. These are the two major differences. Rest of the steps are same. The particles gets charged and then migrated towards, generates corona and migrated towards the collecting surface. So we can discuss more if you have some specific question. Thank you so much. Can we use MEPA for all type of dust? Yes, Mr. Abhishek, MEPA is the most versatile system or the equipment which is going to be in the market. Many systems are under discussions, and surely this is going to have its own space in this industry. What is the temperature influence in the system? Higher the temperature, better is the performance in EGB, because as the gravels gets hot, then there is a perfect insulating capabilities and zero current shown on the screen. So it can go as high as possible up to 700, 800 degree temperature. That is the reason the EGBs are known as high temperature gas purification system. Mr. Narendra Mathur, wet ESP will need slurry handling. Yes, it would need slurry handling, but it is going to be very small in capacity and to be used periodically, not continuous, like scrubbers. Mr. Narendra Mathur, is EGB good for mustard husk and stored boiler? Mr. Narendra, you have, I think, put up a very burning question, and we have been discussing with many companies firing mustard husk and suffering for last so many years, either on ESP or on back filters. ESP, this EGB is going to be a perfect solution for such type of ashes, which has a sticky nature, which has high alkalis, like mustard husk has got high sodium. and it is quite similar to high potassium, which is available in the already tested incineration boiler of a spent wash. So we are quite sure that it is going to have a very good efficiency on mustard husk as well. We are under discussion with couple of boiler companies as well as end users on mustard husk. Mr. Vivekanandan, hi sir, which kind of power supply system of TIASET? Mr. Vivek, we are using 3-phase in ESP as well as in MEPA, both EGB. Next question is Brass Singh, will modification be required in stacked after wet ESP installation? Okay. If it is a non-sulfur based fuel, no modification is required in the chimney. If it is a fuel which has a sulfur and can have a corrosion effect, then chimney either need to be granited, especially on the bottom portion, or can be lined. So it depends on the type of fuel. For biomass, you don't have to do anything excepting proper painting every season. For coal, yes, you will have to do some protection against corrosion because temperature is at saturation after wet ESP or wet scrubber. So what is per module capacity? Yeah, Mr. John Peter, I've already explained that per module will take about 20 meter cube per second. That means about 75,000 meter cube per hour, roughly, each module. So friends, thank you so much with your active participation and questions. The number of questions today gives me a feeling that everyone was connected and understood the concept very well and come out with very nice and good questions, thought-provoking questions. And thank you once again, and see you in my next webinar on 11th of March. Thank you so much. Please send your questions if anything is left out. Bye-bye.